in Cartesian we have do you agree? Look at what I'm doing for polar. Are you doing Wolfram? Just do Wolfram secant cube u. Go to Wolfram.
Sure.
Integration secant cube u. Or x.
All right. Secant cube x is equal to 1 over 2 tan x secant x, because that's the first part we got. Then they did a log.
Yeah.
Oh, God, that is long. Yeah, we would we wouldn't have gotten it today.
Okay, look at this. The length of an arc is the integral of dx square plus dy square. Yeah. What I did is I just forced a d theta in the denominators. So when I force a d theta square in the denominators, I get a d theta square in the numerator, which comes out as d theta.
Wait. How did you get dy is equal to dx by dt? I didn't understand that.
So let's look at this first.
Yeah.
This is the original definition.
Yes.
dx.
Yes.
So I forced a divide by d theta.
Okay.
Divide by d theta square, divide by d theta square.
But then shouldn't you multiply by d square, d theta square?
Correct. In the numerator.
Yeah.
Which comes out from the square root as d theta, because I'm doing it for both.
Oh, yeah.
So what I'm essentially doing is I am doing this.
Yeah, that's I was thinking the square symbol.
Yeah. And then I'm removing it
Ah, got it.
this way.
Yes.
Okay?
Outside.
Now why did I do this? Because I know x is r cos theta,
Yes.
y is r sin theta.
So dx by d theta is equal to r sine theta, r minus r sine theta,
Okay?
and dy by d theta is equal to r cos theta.
And when I substitute it here,
You
what do I-
directly just put it in.
so I get integral root. Oh, there is a plus 1. No. Okay. Sorry, one thing we are missing out. One thing we are missing out. This is two variables. There are two variables here. So when I do dx by d theta, this is a product rule. So product rule says this will be minus r sine theta, where I differentiate this, plus now I differentiate dr, cos theta dr by d theta. Do you agree or not?
Plus cos. Wait.
R is not a constant that I just take out.
Yeah, that's true.
So it is like product of
Got it. Yeah, you're right.
And dy by d theta.
But why is r not a constant? It's not dependent on theta.
No, it could depend on theta. Like for example, the previous question was r equal to cos theta plus 1. you're doing the Desmos thing.
Yes, you're right. You're right. Or it could be dependent on theta. Like if you had a square or something, then the length changes as angle changes.
1 second, I just.
Let me make sure my math is correct. Exercise 29.
Okay. And this becomes r cos theta plus sin theta dr by d theta.
Yep.
You don't need to write all this. Okay, fine. Let's just do it. So if substitution with the square, can you work out the math?
Yep.
The brutal math.
On it.
Do dx by d theta whole square. If you want, do the addition separately outside of the root and integral to make your life easy. Like do dy by dx whole square, dx by d theta whole square, and dy by d theta whole square separately, and just add them up. So all I'm asking you to do is square this, add them up, and tell me what you get.
Square this, yeah.
A plus b whole square, a square plus b square plus 2ab. No need to write all this integral, just focus on this square plus this square.
Yeah, it simplifies to r square plus dr by d theta square.
Yeah.
Yeah.
This is the length in polar form.
Because the two brackets minus r sine theta cos theta dr by d theta get cancelled because of the x and y being positive and negative from the minus r sine theta. And the rest one becomes sine square theta plus cos square theta. You can remove the r square outside and dr by d theta squared outside. Yeah.
Okay. Fine. Let's do one question. Remember that circle?
Yep. Which one?
The quarter circle.
Okay.
So you know that the equation of a circle.
R is equal to 6.
So can you find the arc length using the formula
Integration. Yeah. Wait. The bounds. We didn't discuss. We have to change the bounds.
what is being changed?
D theta. Yeah. So it would be the change in theta. So that's 0.
If r is 6, what is dr by d theta?
0.
0. Yeah, that's a constant. Yeah. So that is it.
It's even simpler than the Cartesian way.
Correct. So it depends on what you're trying to find.
Yeah.
So some questions will be like r equal to cos theta plus 1. I think this was the shape.
Yeah.
Something
Pretty
like
much.
this. Yeah. So okay, this is a fun exercise. Get me the length of the entire shape.
Oh, wait. Okay.
Get me the perimeter of this shape.
Perimeter.
It's cos theta plus 1 whole square.
Yeah.
Plus minus sine theta the whole square. do this. Yeah, that's pretty much my answer till now.
Nobody?
I'm stuck here, but I feel like I can.
Tell me, any guesses?
1 plus cos theta has
Yes.
thing, right?
Correct. 1 plus cos theta. What can I call, what can I make this?
Cos square theta divided by 2.
2 cos square theta divided by 2.
Yeah.
So this becomes Can you unlock your
Sine cos theta by 2 would be sine theta by 2 divided by 1 over 2,
yeah,
which would then become 2 sine theta divided by 2.
yeah.
And then that goes from 0 to 2 pi, which then gives us.
Why is it coming out to 0? It might come out to 0.
Oh, wait. I did it wrong. It's because it's negative.
Yeah.
So it's totaling up the area. So we need to
No,
do
no,
half.
no. It is totaling up the length only. But what I feel is it's positive, it's changing direction. So what we can do is, if it's coming to 0, you can do 0 to pi
Yeah,
and double it.
double it.
If it's coming to 0, I think it's doing one full circle and it's adding up. It's like this. It's like it's saying, oh, I moved one left and one right. So the total is 0.
Yeah, it is coming to 0, so I'll just make it that way.
The square root removes the square.
Oh, yeah.
So
Okay.
2 cos theta by 2 becomes sine theta by 2 by 2. So there's another, this 1 by 2 gives another 2. So it's 4 sine theta by 2. And then we are multiplying this whole thing by 2.
8.
Yeah.
Final answer.
Yeah.
Once you know the formula, it's math. There's nothing to it. Can you? We pretty much covered most of your work except area. I just want to check what do you have.
Well, according to my list of things I need to do. So this is our entire syllabus. So we had double integrals, we had some mass and moment of inertia for plane, polar coordinates and compound regions, line integrals of differential form with respect to arc length, and then Green's theorem.
Okay. Do you have Green's theorem by any chance? If no, then I think you focus on questions.
So
Let's do mass and moment.
Oh yeah, mass and moments here. Here, mass and moment.
In chapter 15.
I believe this is where you're talking about density.
Yeah.
No, we don't have it.
Because I believe what they did here when they were explaining about the integrals, they say we consider it like a volume of a surface. So this is the way they said it.
Yeah. As I've said, like, see, this is okay. This is our.
This is what we did, yeah.
Okay, so
Very
there's
nice.
nothing. No. Yeah. Remember, I said there can be something here.
Yeah.
I'll tell you what that is. Okay, we'll focus on our this thing.
Sure.
Yeah,
I don't have it.
you don't have. We finished everything except area. We can do area later. What I want you to do is go to your chapter 10.
The dash chapter? Or?
Yeah. End of chapter exercise. Or even end of chapter is also good. See, you see this practice exercise? Identifying parametric equations in a plane. Identify the particle's path by finding the Cartesian equation. I think we haven't done most of this, but what we have done is polar to Cartesian, Cartesian to polar. We have done lengths of the curve. If you want to try this, you can try this. And then lengths of the curve in parametric. See, look. Yeah, using that formula, square root. And then try this polar to Cartesian, Cartesian to polar. How do I zoom out? Look at this first. Is it the same? Yeah, it's the same. Symmetry test. Slope of the curve. Let's do from the beginning. We've done this, correct? That day, we've done this.
Yeah, I think so.
Find the Cartesian from parametric equations. No, we did a few questions here. So Oi. Tangent function area. Yeah, let's do length. lengths of the curves. Pick anyone in this, and then pick any two in this. Do it and then let me know once that. There's just two problems. So for you, it's nothing fancy. What I mean by that is, let's say I have some surface.
Yeah.
Previously when I was doing this,
That's the area of the surface.
area of the surface, where I said each box
Is a square.
is a square but of 1.
Yeah.
Everything is 1. So I just could add. But what if I have a metallic surface where it's very dense here and less
light.
dense here and so on and so forth. And where the density is given by f of x comma y.
Okay.
Suppose f of x comma y is x square plus y square. What does that mean? It means when x is 0, y is 0, density is 0.
Got it.
When x is 1, y is 1, density is 2. 1 square plus
Yeah.
1 square. When x is half, y is half, 1 by 4 plus 1 by 4,
It's half.
it's half. So the density varies.
Yeah.
And now I tell you, like this surface is like some weird surface, right?
Yeah.
It has various densities. Now I tell you, get me the area of, get me the mass of this rectangle from 2 to 5 and from 1 to 6.
Couldn't you calculate the area, get a volume, so you need to know how thick it is,
Yes, actually that's the other way to look at it as well. You can say thickness.
and then calculate the mass using density is equal to mass over volume, so density multiplied by. But then, how would you multiply a function with a constant? Well, the volume, would the volume be a function? And can you multiply two? You can multiply two functions. Wait, I'm trailing off.
So yeah, so what you have, like if I make this flat, if I
Yeah.
make the surface flat, like it's like 0, 0 and slightly thick, even thicker. As I move further away, it's,
Thick like anything.
yeah, it keeps increasing.
Yeah, understood.
So if somebody asks me the volume or the mass or whatever it is, whatever the function does, what I do is I simply add that factor.
Add that factor. What do you mean?
Meaning
You just multiply onto it.
the square here
Mm.
is no longer equivalent to a square here
It's equivalent to multiply by fxy.
because of the density or thickness
Understood.
or whatever.
Understood.
So for example, fxy is x square plus y square, and see here I've kept the bounds from 2 to 5 and 1 to 6. So this becomes 2 to 5, 1 to 6, x square plus y square dx dy. Actually, let's not do x square plus y square, let's do x plus y.